oxide. What is happening is the following. Tin, which is symbol is Sn, if you look at the transition metal chart, you'll notice that tin sometimes takes on a +4 ion charge. Other times it takes on a +2. Now, there are certain rules or reasons why tin sometimes takes on a +4 or why it becomes a +2. It has to do with the orbitals associated with the tin. For our perspective, we're just going to work with the fact that it does have these two states. And so the problem becomes, which tin version is it in this problem? Is it going to be the +4? Is it the +2? When you look at question number 23, you know it says 10 Roman numeral 4. That is telling you that the 10, in fact, is in the 4 state. You know that because the Roman numeral told you that. Now, oxide is oxygen. Oxygen is going to assume a -2. Therefore, to balance out the charges and become neutral, I need to have 2 oxygens linked with a single tin-4. And so this is what tin-4 oxide would look like. Let's look at another example. Look at back to this problem again. There we go. Let's take a look at problem number 7. In problem number 7, you got Fe2O3. Now, if you look at your transition metal chart, you will notice that iron, Fe, has 2 different possible states. It could be iron, or Fe, +3, or it could be Fe +2. You don't know which one it is at first. But what you do notice is that the Fe2 is bonded to the O3. Now, this much we know. Oxygen always has a -2. So the total charge contributed by the oxygen group is a -6. Now, therefore, the iron has to be a +6. But there's 2 of them. That means each iron has to be a +3. So this situation is going to be the +3 state. So then you would name it iron, parentheses, 3, oxide. Now, sometimes students confuse that this Roman numeral here somehow relates to this number, which actually is telling you how many of the atoms. It doesn't. This number right here is telling you the ion charge that is on it. This subscript is telling you how many of that atom there are. Now let's move on to the next type, type 3, which is called the polyatomics. A good example of a polyatomic is going to be, let's see here, number 10. Let's make it so we can see a little better. Try it again. All right. Problem number 10 is an example of a polyatomic. To solve for a polyatomic, you need to take a look at the name of the grouping. So right here, you see there's an NH4. If you look at your polyatomic chart, that whole unit is called ammonium. What about the fact that there are two ammoniums involved? You don't need to deal with it. All you got to list in the name is the fact that part of this compound is made up of ammonium. Now what is CrO4? CrO4 is chromate. So if you look up under your polyatomics, you'll notice it's chromate. Once again, all you're doing is providing a name for this subgroup in the entire molecule. So this molecule is ammonium chromate, and it belongs to the polyatomic, it's made up of polyatomic ions. Another example of a polyatomic can be found as number 20. Number 20 is magnesium hydroxide. So now we're given the name and we're supposed to solve for what it is. Well, magnesium itself is not a polyatomic, it's just a single ion, magnesium Mg. If you look up on the chart, magnesium is a +2. If you now consult your polyatomic chart, you will look up and find that the word hydroxide stands for OH. OH is made up of oxygen, hydrogen, and it's one unit. These two are locked together so tightly that they always work as a unit. But here's what's interesting about that unit. The oxygen-hydrogen unit has a -1 charge to it. And you know it does because your polyatomic chart has that showing. So the OH is a -1. Magnesium is a +2. I clearly need to have two of these. So I'm going to put a bracket around this, and I'm going to put a subscript here of 2. Why put the brackets? You put the brackets so that the chemist knows it's the entire polyatomic. There's 2 of the entire group. It's not 2 of just hydrogen or 2 of just oxygen. It's 2 of the hydroxides. Now, the type 4 is going to be a non-metal with a non-metal. An example of that is going to be number 5. Number 5 says N2H4. N2